So as we discussed tools of SQC. The tools of SQC are either process control or product control or both. So what are the how can you achieve the control process control means process control can be achieved by control charts. Again, the control charts are of two types: control charts for variables and control charts for attributes. Under control charts for variables, we are going to discuss X bar chart, R chart and sigma chart, which is nothing but standard deviation chart. Under control charts for attributes, we discuss P, which is nothing but fraction defective, NP, number of defectives chart, C chart, number of defectives per unit. So, before discussing all this, let us see what does a control chart consists of, what does it conclude. Control charts are introduced by Shewhart. He is one of the statistician, and its a name itself tells that it's a graphical representation consisting of a two-dimensional bivariate axis. On the x-axis, always we are going to consider the sample number. On the y-axis, always we are going to consider the corresponding statistics. If it is a x bar chart, here it's a fixed one, sample number n. On y-axis, we will consider x bar. If it is a range chart, on y-axis we will consider range. If it is a sigma chart, on y-axis we will consider the standard deviation. If it is a P chart, we will consider on y-axis fraction defective. If it is an NP chart, we will consider number of defectives NP on y-axis. If it is a C chart also, we will consider C on y-axis. Got it, girls? The x-axis always a fixed one, on y-axis. Depending upon the chart, that corresponding statistic is going to be the on y-axis. X bar or range or sigma or P or NP or C. And also it consists of two dotted lines and one solid line. The upper one, the one which is the solid line, the dotted line which is above the solid line is called upper control limit, which we call as UCL. The dotted line which is below the solid line is called the lower control limit, which we indicate with LCL. The middle line we call as control line. It consists of three lines, out of which two are dotted and one is solid. The middle solid line is called control line, and the dotted lines above the line which the one which is above the control line is called UCL, upper control line, and the line which is below the control line is called the lower control line. Now, this is the structure of the control chart. Either whatever may be the out of these 6 chart, whatever may be the control chart, this is the structure of a control chart. Moreover, after drawing this control chart, to draw this control chart, you should have UCL, you should have LCL and CL. So, these two are called the 3 sigma limits. So, how do you frame UCL of any control chart, either X bar or sigma or R or P or NP or C? We write, let us say whatever may be, if T is the statistic, we write that as T plus 3 into standard deviation of T. If it is LCL, we will write the same with negative sign, 3 minus 3 into standard deviation of T. If it is a control line, simply you will write as T. Again I will repeat, for UCL upper control line, the formula is statistic 3 plus 3 standard deviation of T. Lower control line is T minus 3 standard deviation of T, and control line is T. For example, if it is a X bar chart, the UCL will be X bar plus 3 into standard error of X bar. For LCL, X bar minus 3 standard deviation of X bar, and CL it is nothing but simply X bar. Expectation of T. So you should know, again you should recall what is the standard deviation of mean, what is the standard deviation of sigma, standard deviation of p and all. So standard error of p and all. So we have came to know that what is a control chart, what does it consist of, how to write the UCL, LCL and CL of any control, any statistic. Now, so all these together, as I said you, those are called 3 sigma limits. Okay, what are 3 sigma limits? 3 sigma limits are nothing but expectation of t plus or minus 3 standard error into t are called the 3 sigma limits. Upper control limit is e of t plus 3 into SU of t. Lower control limit is e of t minus 3 into SU of t, and the control limit is e of 3. These 3 together are called the 3 sigma limits. To construct any control chart, you should know, the major point you should know is nothing but the 3 sigma limits. Okay, thank you.